Hello friends, welcome again, and in this video let me just discuss with you one more question from that NPTEL assignment section that we are talking about or discussing with you. And this question I have taken from machine design section, and as you can just see, this is related to basically welded joint, just go through it, design of welded joint basically. So just go through this question, try by yourself, see what mistake you are committing, then I think you will realize this. So that would be a better way, and then see the explanation part. Okay. So here you have been given a T joint. Basically, you are having two plates which have been joined in the form of a T section, and they have been welded, and the details have been given to you. So the same information what I have done is I have presented you in this way. I have drawn the figure, and now I am going to explain you with the help of that figure over here. So what it says, first of all, see, it's saying a T joint of steel plates. So what I did is I took two steel plates and took the configuration in T shape, which is subjected to a 350 kilonewton load is developed using. Now, how that load is being applied, that is not mentioned over here. Using 4 intermittent 4 double fillet welds of length each. That means you have to, now this line you have to read carefully. Okay. What you have to do is, he's saying 4 double fillet welds. That means these are not 4 fillet welds. These are 4 double fillet welds. What does it mean? It means that, for example, if you are joining these two plates this way in the form of T section, then T form, then let us say if you are, obviously if you have to weld it, then one weld you have to put it over there here and another on the other side. So that way you are having 4 welds on this side, and similarly you are having 4 welds, similar welds on the other side also. So how many set? You are having total 4 set, 4 double welds. So one double weld over here, one double weld over here, one double weld over here, one over here. That means one over here, another over here, one over here, another over here. So that way in total you are having 8 welds that you are using to join these two plates, and they are the fillet welds. They will look like this way, and at an interval of 100 mm. Whether that information is relevant for us or not, we will see it. The allowable shear strength of the weld material is this. Now, allowable shear strength जो उसने weld material की दी है, वो आपको दी है उसने 400 megapascal, sorry 100 megapascal. And he is asking us to calculate the leg length of that fillet weld. Leg length means I have taken one of the fillet weld and I have shown it over here. So this is the fillet weld that you can just have a look over here, and this is the leg length, and this is the length of the weld, of each weld, which is 40 mm he has given you. So such welds are there, total in 8 are there in number. So this is how the situation is. What he says now, determine the leg length, H you need to find out. Now if you have a look over here, he has not nowhere mentioned about the loading, type of loading, type of joint. He has simply given, I have formed a T section and I have joined it with the help of the fillet welds. Some of you may say that okay, I can apply load this way. Some of you may say no, you have not applied load this way. You will say that I have applied on the bottom plate this way and on this plate this way. You can think of like uniformly distributed from top to bottom. You are applying this way. So if you are applying the load this way, then this joint will become parallel fillet joint or longitudinal fillet weld, welded joint. What does that mean? That means that if the force applied is parallel to the direction of welding. Where is the direction of welding? Yeah. This is the direction of welding. So direction of welding is this way. So if force is parallel to the direction of welding, that means we will say this is a parallel fillet weld or longitudinal fillet weld. And in this case, all the welds in such situation will be subjected to pure shear only. That means this vertical face will be subjected to shear, as well as the bottom face of the weld will also be subjected to pure shear. So this weld is purely in shear, and the design is simply based upon shear only. So in that case I will have no trouble, because he has given me the allowable shear strength for that weld material. I have to design it based upon the shear. My job is done. So no issue. Now some of you may say that why you are taking this way. I will not take this way because he has not very clearly mentioned that. So if he has not clearly mentioned that, the other possible mode could be this way also. You are pulling it from the top, and obviously as a reaction force is acting on the bottom plate, then this will become what? In this case, force is acting perpendicular to the direction of welding. Direction of welding is this one. So perpendicular to the direction of welding, it means a transverse fillet welded joint. All the welds, they are in transverse loading condition. If that be the case, then if you see, this vertical face of the weld will be subjected to shear, whereas the bottom face of the weld, this one, will be pulled down. That means a combination of shear and tension. So that means this kind of weld is normally a combination of tension and shear. Now, to design such kind of welds which are in transverse loading, some of you can approach through like tensile, that you can make them fail in tension also, and some of you can say that okay, I will make it fail in shear. But since he has very clearly given you the information that this is subjected to that the maximum allowable shear strength is this much, you have no choice to consider it that he is going to fail in shear only, because he has given no data for tension. So if that is the case, then it is straightforward that whether it is a transverse loading case, then also it will be, you are making it fail in shear, or whether it is a parallel fillet weld, in that case it is going to fail in shear only. So it means I am not bothered here how he is applying the load, because since this is going to fail in shear for both the modes, so in that case I have to write down the equation of shear in this case. And you know, in case of fillet welds, we consider them the weakest at the throat section, and therefore if at all they fail in shear, they are going to fail at the throat section of the weld. And where is the throat section of the weld? Each weld is over here, this one which I have shown you. This is at 45 degree, you know it. If that be the case, now tell me the maximum value of the shear stress that is induced, and that will be at the throat section of the weld. You will say what is the force that you are applying divided by the total throat area of all the welds. All the welds resisting that force. Resisting which force? P. Because P resisting force P. And what is the total throat area? You will say if I am applying force P, what is the throat area of one weld? This is the T, throat thickness. This is T. And what is the length of the throat? T. That will be equal to the length of the weld only. So that means throat area of one weld is TL. How many such throats are in total which are resisting this force? There are total 8 throats. That means since there are 8 welds, so 8 throats are going to, so this is the total area. Throat area which is going to resist this force is going to be this one. It means I can write P divided by, now I am writing T in terms of H. You already know that 0.707 H into L. If that be the case, now it becomes simple. Now he is saying that if I am applying force this much, that is a 350 kilonewton, and length is this much, and if allowable value of the shear stress for the weld material is this much, then how much is going to be the leg length? So simply it implies that if I take the allowable value as 350 or 100 megapascal in Newton per mm square, so I need to correct the units over here. Load that you are applying is in kilonewton, so convert it into Newton, and over there 0.707 H I want to find out, and length of each weld is how much? That he has given me 40 mm. So interval is not relevant for me, at what interval is. So we are assuming that uniformly at uniform interval that he is placing them. So from here I can find out the result. So I think just you may have found it out. Let me just check what was the answer. So somewhere, if you can calculate, you can just see it. Okay, so it is H is going to be 15.45. So this is going to be the leg length. Okay. So this is how you are going to approach this particular problem. So see, the only point that you have to take note of in this problem is that interpret the information very correctly, if you can interpret it correctly, rest part is of very basic understanding that you have of this particular topic, and that you can utilize to solve this problem. So I think, I hope you may have found this problem relevant enough. So similar kind of problems on the similar lines or that we have, or other problems also in the NPTEL part, where we will be bringing you on regular basis, so that you can get the idea that the level of questions and all that conceptually how they are covering. So see you in the next session, with the next video, with the new questions. And till then, bye. Thank you.